In this video, I'm going to show the setup for Windows simulation development for both the application as well as the embedded DOS itself. I'm also going to show MS-DOS debug-like application which we can access the target memory. So in this setup, I have a USB hub and two USB TTL dongles here. Each Windows application talk to one of the ports. Let's say the Windows console application talk to one of this port, and the other one is embedded DOS is talking to this one. The RX and TX pins are crossover in here, and the ground is connected. So anything I send through this port will receive on this port, and anything sent from this port will receive here on this port. On Windows here, I have two applications running. One is my Windows util, which has the UI here. And the second one is the embedded DOS, which will talk to the other port. So let's stop here and we can take a look at the output. If I run it, the output will show embedded DOS, blah, blah, blah. And I'm going to show how to debug. If I find a bug, in both the application or the DOS itself, I can really debug on the Windows instead of using the GDB and the ST-Link to debug on the STM32. Here, let's say I have found one bug here. I type time, and time is presented in the format of month /30 and date and the year. But in order to enter this in, we ask user to enter mm-dd-yy to change. Let's say I want to change this one to 21 to 2023, and this will be accepted. The current time is in this format, and the hour, semicolon, minute, semicolon, and 59. We are asked to enter in this format, which let's say I want to say 21 dash minute, well say 23 dash and 00. Now here we have found two possible improvements. One is this a bug here. Even though we announced we are supporting this format as the entering of the time, we failed. And in here, we were trying to set better, let's say time again. And if I enter, let's say October 21, 21st, and 2023, we get an error here. So let's see how I can fix this bug. So I could just go here and stop the debug here. Find the code that's doing here first. Let's see, we are saying current time. I want to do / and / here. And in here, instead of looking for the dash, I'm looking for that one. So the time is correct now. And date is correct. Time, the entering looks right to use the semicolon, but the format of prompt was wrong. So I'm going to use /. I'm going to semicolon. And now I'm going to rerun it. And run the application. Here, I'm going to see the time here. I'm going to enter this and 21 and 2023. Boom, it's accepted. And then time, you see time of this format has been changed. Let's say I want 21, 26, 27. Of course, because this time is from the Windows system time, which is correct, I'm not going to bother to really change the time and date, but on the real target, this is important. Now I'm going to switch to the real target. Here is the real target connect it with the ST-Link to the debug port here. Serial port connect to the STM32F401. To program the device, we're going to use the Visual Studio Code with the extension installed. Like we can build and then we can download it. So in here you will see it's downloaded. Is it download? Unable to match frequency. Okay, I'm going to format everything. So currently there's nothing on the disk or on the flash. So I'm going to copy the time first, which we have debugged previously. So make com time. So it's now automated. So once I type this command, it will issue to the host, and the host will do the make and then copy file over. So now we can see there is a file called time.com. The timestamp on this for this particular file was wrong. The date was wrong because today's date is October 30th. So I'm going to modify the time, say this time, and the date is October 26th. Now I'm going to /, we fix that one, 30, and it's done. Now the time is 9:55, which is 21st, 55:00, and it's now I'm going to make another file called debug. Okay, here I'm going to list the file, and there is a first file. It's called time.com. It was created at October 26, 2023, and the second one created at October 30th, 2023, 21:55, which was the one that we just modified the time. The debug.com is created to inspect the memory. It's very similar to MS-DOS debug. Let's type debug, and we have a prompt. So let's say help, and there are several commands. One is called D, and the second one was H, and then E and Q. When we try to calculate the address, sometimes we need to do some basic hex calculation. Instead of bringing up the calculator, we can do some simple hex add and subtract in this software. So let's say I want to display some registers, and it has the address, certain address. Let's say flash can start from 08000000 and then 8400, and that's the first one was the sum of the two hex values. The second one was the subtract. Let me show you the other command here, which is D display. So I'm going to display the memory of my NAND flash. So 08008000. So what you see here is the directory here. So that we know that there is a time.com and debug.com. So time.com is here, debug.com is here, and the rest of information can be the date as well as the size and the location. So the real content of this NAND start from 08008400, which is the beginning of the time.com start from here. When we execute the code, it's execute start from here. So the other command is the E. Okay, so the E is modify the data. Let's say I want to display 40020800. This is the port C. Okay, this is port C. So here is everything 0. Now let's make blink. Okay, now I'm going to show blink, and it's start blinking, and I can quit. Now I'm going to debug and show the 40020800, and you will see the address here, and here are the this is the initialization. I'm going to show you how I can use the debug to turn on and off the LED. So the LED is turning on here. Let's say E40020815, and current value is 20, which I'm going to turn this on will be 00. You see, turn this on. So if I'm going to do this one more time, E40020815, enter. I'm going to 20, turn off, 20, turn off. So this tool allows me to modify the memory. We know in STM32 registers are memory also. So if we want to experiment the LED, let's see if I can do let's say reboot. Okay, now I'm going to debug. If I want to turn on the LED, let's say E4002081520, it will not turn on. Okay, it will not turn on. However, the 40020800, we know this needs to be 04. Let's modify E40020804. 0403, and this is 04. Okay, as soon as I modify this value, this is turn on the make this pin to be output. Now the LED turns on, then I can E40020815, and now I'm going to turn this off by putting 20, which is the pin is 13 pin. Turn it off. And help. This last command is exit. We can queue to exit. Okay, so in this video I have shown one is using the Windows simulation to do the development. By the way, the whole debug was developed on the Windows. And secondly, I show the debug.com to do some memory manipulation. We can inspect and modify the RAM to the things. In the future, we are going to do SPIs, and this debug.com will helps a lot.